Density is the amount of mass in a given substance. So it's how much matter occupies a given amount of space. It could be written as density is equal to mass over volume or m over v. The units for mass is grams. The units for volume is milliliters or centimeters cubed. So for liquids, generally the units we use is grams per milliliters, and for solid is grams per cubic centimeter. Density depends on the mass of each particle. In addition, it also depends on how close the particles are to each other, so how compact the material is. For a given volume, if the particle is more massive or more compact, the density will increase because mass is directly related to density, which means if the mass increase, the density will increase given that the volume stays constant. However, it does not depend on the quantity or the amount. Whether I have a cup of pure water or a bathtub full of pure water, the density of water will remain at 1 gram per ml. It also does not depend on the shape. So if I have water in a cup versus the same pure water spilled on a table, the density of water is still 1 gram per ml. Another example of this is if I have a pure gold ring versus a pellet of pure gold, the density is still the same. So the density of water is 1 gram per ml. For most substances, the density of the substance decreases with increasing temperature. So for example, if I have a material that is cold, the particles inside here will be very close to each other. Density is mass over volume. If the particles are closer together in a given amount of space, there is going to be an increase in mass. Since density is proportional to mass, if the mass increases, the density will also increase. However, if the same particles are heated up in a given amount of space, there will be less particles because the particles will move around and there will be more space in between the given particles. So density is still mass over volume. My volume for the container is the same. Because the particles move around more, there is going to be less particles in that same amount of space. Since the mass decreases, the density will decrease. Because again, density is directly proportional to mass. So let's look at this example 1 here. We have 2 containers. They are 2 meters by 3 meters by 0.5 meters. So the dimensions of the container is exactly the same. Block A has less particles. Block B has more particles. Let's assume that the particles have the same mass. So question A asks, are the masses the same? The answer is no. The individual masses are the same. However, in block A, there's only 4 particles. So we could say there's 4 grams. In box B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 particles. And since each particles have the same mass, B is going to be 9 grams. Therefore, B is going to be more massive because in a given volume, B has more particles. So this is 9 grams if we assume each particle weighs 1 gram, and A will have 4 grams. Are the volume the same? Yes. Since this is a rectangular prism, volume is what? Length times width times height. The length is 3 meters for both. The width is 0.5 meters for both. And my height is 2 meters for both. Since the dimensions are exactly the same, if I multiply these three numbers, they're exactly the same. Are the density the same? The answer is no. Remember, density is mass over volume. We know that the volume is the same, but the mass is not the same. We stated in the previous slide that density is proportional to mass. Since the mass of B is much greater, therefore density of B will be greater. Since density is proportional to mass from the previous slide, the one that is more massive will have the greater density. Block B has a mass of 9 grams versus 4 grams for A. Density of B will be greater than the density of A because B is more massive than A. In a given volume, if the volume stays constant, density is proportional to mass and they're directly related. In the second example, which would have a greater volume and mass, and why? So we have a kilogram of feathers and a kilogram of bricks. Since they are both 1 kilogram, they will have the same mass. So the mass here would be the same. Again, they're both 1 kilogram. So 1 kilogram equals 1 kilogram. However, the volume will be different. The greater volume will be the 1 kilogram of feather. Why? I need more feathers to make up a mass of 1 kilogram versus the number of bricks to make up 1 kilogram. So now let's compare the density. Density is mass over volume. We said the mass is the same. So density is proportional to 1 over volume. That means as the volume increases, density will decrease. The greater the volume, the smaller the density, because they're inversely related. The one with the greater volume will have the smaller density. So in this case, that would be the feather, because you need a greater amount of feathers to make up 1 kilogram. Difference in densities cause object to float or sink. Water has a density of 1 gram per ml. If I place any object with a density greater than 1, it will sink in the water. Any object with density less than 1 will float on water. So if I had these following substances and I had to layer it in a graduated cylinder, the heaviest density will go to the bottom. The lightest density will stay on top. So here, gold has the highest density. It is 19.3. So gold will sit on the bottom, followed by lead, which has the second greatest density. Then aluminum, which has the next greatest density. Then it will be water. Following water, we will go to ethanol, which is gasoline. Then it will be ice. This is why ice floats in water, because ice has a smaller density than water. Followed by oak, which is wood, a type of wood, and then air. If I had the graduated cylinder full of water, aluminum, lead, and gold will sink because their density is greater than water. Ethanol, ice, oak, and air will float above water. After the top water layer, it will be ethanol. After the ethanol layer, it will be ice, then oak, and then air. Here's another example. Ships are made up of steel. Steel has a density of 7.85 grams per cubic centimeter. So if I have a piece of steel, like a pellet, and I place it in water, it will sink because the density of water is 1, which is less than the density of steel. So then how do ships float in ocean water? The density of ocean water is approximately 1.020 gram per cubic centimeter. It changes based on the amount of salt that is present in the ocean. The density of ocean water is 1.02, while the density of steel is 7.85. However, ships made up of steel still float in water. So what they do is they change the volume. Remember, density is mass over volume. So if I don't change the mass because we are using a given amount of mass, we notice that density is proportional to 1 over volume. As volume increases, density will decrease because they are inversely related. So as one goes up, the other goes down. So what they do is they take steel and they increase the volume by pounding it into thin sheets. Since the volume increases exponential rate, the density will decrease exponentially too. As we discussed, density is mass over volume. Volume can appear the following 3 ways. Number 1, it could be given to you in the problem, or you are going to be solving for it. Number 2, it will be a geometric shape. We solve the volume using the volume formula for each particular object. So for a rectangular prism, volume is length times width times height. You might get a sphere or you might get a cube. So use the appropriate volume formula from geometry to calculate its volume. However, sometimes you will be given an irregular shape. When the object is not geometric, we use something called the displacement method. For the displacement method, we obtain a graduated cylinder. We put a certain amount of water in it. We record the volume of that water. We read the water at the bottom of the meniscus. This water we read is called the initial volume. After reading the initial volume, we take our irregular object and place it inside the graduated cylinder. Once the object is fully submerged on its own, we read the new volume. That new volume is called volume final. The difference between the final volume and the initial volume is the volume of the object. If you are struggling with the basic algebra of rearranging the variables, use the density triangle. The density triangle has the mass on top of the triangle or the apex of the triangle, and density and volume are on the bottom. If I'm solving for mass, I cover mass. So the formula for mass becomes density times volume. The vertical line means to multiply. If I'm solving for density, I cover density. So density becomes mass is on top, and you see the horizontal line, that means divide over the volume. And that is the formula of density, mass over volume. If I'm looking for volume, again, I cover the volume. And we notice that volume is equal to mass on top. You see the horizontal line, that means divide density. So the formula for volume is mass over density. It doesn't matter if you use the density triangle or the algebra. Use what makes you feel more comfortable and just do it correctly. So let's look at this first problem. It says, what is the density of a billiard ball that has a volume of 100 centimeters cubed and a mass of 250 grams. First, identify the variable. We know we're looking for density, so D is what we're looking for. The volume is 100 centimeters cubed. If you can't read this, look at the units. Centimeters cubed represents volume, and it has a mass of 250 grams. Units for mass is grams. So the formula we need is density is equal to mass over volume. I'm going to plug in, that's 250 grams divided by 100 centimeters cubed. This equals to 2.5 grams per cubic centimeters. Grams divided by cubic centimeter is my units. Now we need to go back and do sig figs. Volume, there are 3 sig figs because there's a decimal and a significant digit in front. So those zeros are significant. For mass, there's only 2. This is a trailing 0. So my answer needs 2. 1, 2. So this is the correct answer. Number 2, the density of silver is 10.5 grams per cubic centimeter. If you did not know that is D, look at the units. Find the mass. So we're looking for M. That occupies this much space. That's my volume. So that's 965. Units for volume is centimeters cubed. So density is equal to mass over volume. We need to isolate the M. So we need to multiply by volume on both sides. The volumes cancel out. So mass is equal to volume times density. Subbing in 965 centimeters cubed times 10.5 grams per cubic centimeter. This equals to 10,132.5. The centimeters cube on top cancels out with the centimeter cube on bottom. So we know the units are grams. Now I need to go back and do sig figs. 10.5, there are 3. 965, there are 3. So my answer needs 3. Starting at the left, we count 3. 1, 2, 3. 1 to the right, that remains 101. We have to put placeholder. This 1 is in the hundredths place, so we have to make my 1 in my final answer in the hundredth place. If you don't want to memorize the formula, you can also use dimensional analysis to solve for this problem. As usual, start with what's given, which is 965 centimeters cubed. Now density becomes a conversion factor. Density is 10.5 grams per cubic centimeter. It can be rewritten as 10.5 grams is equal to 1 cubic centimeters. So in a volume of 1 cubic centimeters, the mass is going to be 10.5 grams. So diagonal units have to be the same. So this has to be centimeters cubed. The number in front of centimeters is 1. The units cancel out. This is equal to 10.5 grams. After solving the math, you should get the same answer as this. Pause the video, solve this problem on your own, and then check your answer. Find the volume. So we are looking for volume of a 35.2 grams. Since the units are grams, we know this is mass. It's 35.2 grams. It has a density of 1.6, so D is equal to 1.60 grams per ml. We're solving for volume, so density is equal to M over V. Since volume is in the denominator, we need to bring it to the numerator to solve for V. So I'm going to multiply both sides by volume. So V times D is equal to mass. To isolate volume, I need to divide both sides by density. So volume is equal to mass over density. Plugging in, this is 35.2 grams over 1.60 grams per ml. This is equal to 22. The grams cancel out with the grams on the bottom. Since milliliter is the denominator of the denominator number, it flips and comes to the top, so the units are milliliters. Now we need to go back and do sig figs. There are 3 sig figs here, and there are 3 sig figs here. There's a decimal, significant digit in front, so that's 0 is significant. My answer only has 2, so I need a decimal and a 0. This one too, we could solve using dimensional analysis. I start with the unit by itself. In general, unless you are converting both units, you start with the one by itself, which is 35.2 grams. Our density now becomes a conversion factor. It tells you that there's 1.60 grams in 1 milliliter. So grams, the number in front of grams is 1.60. This is equal to 1 milliliter. The grams cancel out. After you do the math, you should get the same answer as here. Number 4, we have a rectangular block of lead. It has 20 millimeters times 30 millimeters times 45 millimeters. It has a density of 11.34 grams per cubic centimeter. It wants to look for the mass. So we are looking for the mass. We know that density is 11.34 grams per cubic centimeters. So that means I know my volume. Since it's a rectangular block, this is a regular geometric shape. Volume for a rectangular block is length times width times height. The dimensions given are 20 millimeters times 30 millimeters times 45 millimeters. So volume is equal to 20 times 30 times 45, which equals to 27,000 millimeters cubed. Millimeters times a millimeter is a millimeters cube. So if you notice, the units are not the same. So I need to convert my millimeters cube into centimeters cube. So I'm going to start with what's given. Millimeters cubed. So diagonals have to be millimeters. If you don't know how to go to centimeters directly, go to base. Bigger prefix is the meters, so that's 1. There's 1,000 millimeters in 1 meters. Do you see how the units are cubed? So I need to cube the entire on top and bottom. Now I'm going to do my diagonals again. The meters cubed canceled out. And so now meters is my diagonal. And I'm going to go to centimeters. We know that 1 meter has 100 centimeters. But we need to know how many meters are in centimeters cubed. To do that, I cube it. And in the math, you get 27 centimeters cubed. Remember, when you cube it, that means I need to multiply 10 to the third millimeters times 10 to the third millimeters times 10 to the third millimeters. On top, it will be 1 meter times 1 meter times 1 meter. For the centimeter, it's going to be 100 centimeters times 100 centimeters times 100 centimeters. And on the bottom is 1 meter times 1 meter times 1 meter. You could also go directly from millimeters to centimeters. That would be 10 millimeters cubed in 1 centimeter cube. Or you could set it up the way it was set up. So now I could plug in. We know that mass is equal to density times volume because we solved it in the previous slide. So this is going to be 11.34 grams per cubic centimeters times 27 cubic centimeters. The centimeters cancel out. It goes to 306.18. Going back, we're going to do sig figs. There are 4 in density. For the volume, there is 3 here. There is 3 here. There's 3 here because each of them have a decimal and a significant digit in front of the 0. So all the zeros are significant. So my volume will also have 3. So the least amount is 3 because we're multiplying and dividing. So it's 1, 2, 3. 1 to the right. So this is 306 grams. You could also solve this dimensional analysis and you'll still get the same answer. In problem 5, George puts 25 ml of water into a graduated cylinder. After adding a solid object, the water level in the cylinder rose to 45 milliliter. What is the volume of the object? So we know this is an irregular object using the displacement method. So what we have here is we have a cylinder. In the cylinder, we have water. This is my V initial. My V initial was 25 milliliter. An object was placed in and the water rose. This is my final volume, which is 45 ml. To find the volume of the object, volume final minus volume initial, 45 mLs minus 25 mLs. So this is going to equal to 20 mLs with the decimal. Add and subtract is the least precise position. The 5 is significant for both. So the least precise position is the ones place. So when I subtract this, I need to round right here. To make that 0 significant, I either put a decimal after the 0 or write it in scientific notation. Either or is correct. So density is what we're looking for. We know the mass is 15 grams. We found the volume of the object in part A, which was 20 milliliters. So density is equal to mass over volume. Plugging in, we get 15 grams divided by 20.0 ml equals to 0.75 grams per ml. Going back and doing sig figs, there's 2 here. There's 2 here because there's a decimal significant digit in front of that 0. So that 0 is significant. So my final answer has 2. So for density, identify the variables. If you identify the variables correctly, the equation will come out. If you cannot do the algebra, use the density triangle. You can also avoid the math errors if you just solve it using dimensional analysis.